Alrighty, welcome everybody to the distribution team demo for Thursday, August 24, 2023. Today, I'm just going to do a quick demo of some of the updates regarding our CI cluster maintenance and provisioning long-term strategy. I've got an epic linked there in the distribution demo notes document. The overall purpose of this epic is to take a moment to think about how we manage our clusters. What we've noticed a lot so far is that given how rapidly Kubernetes releases new minor versions, especially, we're having trouble keeping up with the process of provisioning clusters and installing dependencies on them, and then connecting them into CI and updating the CI configuration to reference them. It tends to be the longest part of adding support for a new version of Kubernetes, longer than just updating the components that might need new API versions or spec references, that kind of thing. And so we've been looking into some options. For example, developers like to use K3s or K3D or Kind locally for spinning up quick clusters for testing. So we've done some testing of that in CI as well. And then we've also taken a look at vCluster, which I believe Dustin recommended. So thanks for that. So I'm going to quickly share an update on where we are at with those, and give you an idea of what this looks like right now. So this is the epic linked here in case you're curious. So we've done testing so far with K3s, Kind, and vCluster. I'll start with Kind. So this has been our long-running developer local testing solution. And it's a great utility. The difficulty here when testing it for CI is that we need a node that has at least Docker and Kind installed, as well as some other helpful tooling. Actually, I haven't looked at the script in a couple of weeks, but it's something like this. We need kubectl, GitLab Runner, Helm, Kind, Docker. So it's fairly straightforward. It'd be easy to make a golden image of this or use something like Ansible to provision nodes. And this worked okay with the GCP instance. It came up, but then, of course, there's some challenges in terms of infrastructure. We need to give that Helm installation the external IP of the node. So that's a slightly different process. And then the bigger problem is this is a kind of a one-off node. So how many releases can this node take? Likely one is how we'd probably provision it. So how can we tell in CI whether we're saturated on these nodes and we need more spun up? There's no kind of intelligent autoscaler that's bringing up more of these nodes when we need them. Especially important because QA runs against a publicly accessible instance. And so it needs to have that infrastructure around it to be publicly accessible. The other approach, instead of one-off instances, was to do it within Docker and Docker inside just GitLab.com runners. This unfortunately timed out. You don't get to make much in terms of requests for the pods that you get under the hood with GitLab.com runners. And unfortunately, GitLab itself is just a little too heavy to run in that kind of environment reliably. Even if it could, there's no way to keep that environment running for the duration of the CI pipeline because QA needs to run against it. But by the time that job was done, it would be terminated. Pause me at any time, by the way, if anybody has questions. K3s is a very similar story. K3D is very similar to Kind, so this is really just the tooling under the hood, but this actually went slightly better. The release actually fully came up in this pipeline, so GitLab was able to fully start, and then I wasn't able to get it to do it in the next few tries. So that was after 10 minutes of failing to start. Now, a lot of that duration probably comes from needing to pull really heavy images. These are ephemeral runner nodes. Therefore, they don't have a cache of all the images that we use for the Helm charts locally. So pulling is probably taking most of that time. And even then, like I said, we don't get to make much in terms of resource requests for those pods. So it's just not a reliable environment, but very easy to implement. Moving on to vCluster. So this is one that, like I said, Dustin had recommended, and it is a free and open source tool that runs K3s under the hood, actually. And so the concept here is that you have a vCluster CLI, and the way that we would configure this likely is that instead of having individual GKE or EKS clusters that are created at certain versions, we could create one master cluster, probably in each provider still, but one, for example, one master GKE cluster, and just let it float to the newest version. The underlying version of that cluster isn't really significant to us. We would use that as a platform for individual virtual clusters managed by vCluster. So effectively what happens is vCluster will create a namespace in that cluster and deploy K3s to it. And it's got some other components as part of it that keep it isolated to that namespace. And so you just tell vCluster what namespace name you want and the version of Kubernetes you want it to run. This is effectively just a stateful set in that namespace. And so it comes up really quickly because K3s is so small. And it actually provides really great isolation, and you can even control how isolated it is. So when I was testing this in the merge request, effectively what I did is I did the same process we'd normally do for adding new jobs, but as part of our automation tooling script, I added one function that will say, if there's no environment variable named vCluster name, then I know vCluster is not configured, so I'll skip. But if it is configured, which is just an environment variable in the job, I will run vCluster connect to the vCluster name. So effectively at this point, we've already connected using the GitLab agent, the GitLab Kubernetes agent to get connected to that Kubernetes cluster. And so since I already have a connection to that cluster, all I have to do is call vCluster connect, and it effectively just changes your Kubernetes context to point directly to that virtual cluster. So you're actually completely bypassing the underlying cluster's API server and going directly to the one that's provided in that namespace. And then we ensure that the namespace we want exists in that virtual cluster too. And then we set the context to always point to that namespace, just like we do for the underlying cluster. And the rest is much the same. We connect to the cluster. Here's vCluster name. So I just name it K8s 126. Obviously, if we made a 127 cluster, the name would change to match that. And that's really all there is to it. So in the pipeline, you can see here now we have 126. So there's review. And review specs will fail for now because not all the infrastructure is up. But you can see here for review, I will scroll up to here. So set context. So this is using the GitLab agent to connect to the Kubernetes cluster. So you can see we connected to the GKE 125 CI cluster. And then because on this job, I had that environment variable with the vCluster name configured, it will actually connect to it. So you can see it's using vCluster K8s 126. In that namespace, there's a load balancer endpoint that gets you directly to that API server and control plane. And then you can see that it switched the kube context to that virtual cluster. And so now the rest of the steps are the same. We deploy and it waits and restarts Toolbox and then saves some environment variables and it's done. Now, the reason specs is failing right now is because we don't have cert manager or external DNS configured, which we can look into, but that requires shifting some infrastructure around, but very doable. So to give you a live look here, move my zoom bar. I'll bump up the size of this here. So on the top here, we are looking at as if we had connected only to the 125 cluster. So if I were to list out the namespaces here, you can see we've got our normal Helm charts win. This is where all our other workloads currently are deployed. And then we've got the vCluster K8s 126 namespace. That was what was created when I ran the command to create the vCluster instance right here. That's that namespace. So if I were to look into that namespace, you get some prefixed items. You can see basically everything that is technically deployed to the virtual cluster. It effectively copies what pods need to run so they can run on the underlying host. So these are prefixed with the host cluster before it. Now at the bottom, I have used vCluster connect or kubectl switch context to connect only to that vCluster instance. So I'm actually bypassing the underlying host's API server and connecting directly to the one that's hosted by K3s in that namespace. So now you can see if I compare the namespaces, they're different. I have Helm charts win, but that's just because I picked the same name as the underlying host. But you can see, for example, I don't have that vCluster K8s 126 namespace. I don't have the GitLab agent namespace, which makes sense because I don't have an agent connected directly here. And so we're now in a technically separate virtual cluster. So I can jump into Helm charts win, and here's my release that the CI environment created. And so everything's running as it would normally. I have ingresses picked up by the Nginx that I deployed here. This is where the only limitation is at the moment, is that Cert Manager can't see inside this virtual cluster. There are ways that I'm looking into the documentation now to actually expose that, and it's fairly straightforward in a common workflow, but that's the only reason CI is not passing right now. But what's really excellent about this is that for charts and operator especially, it's really hard for us, since we only have one cluster at a certain version, to completely isolate releases, because there are cluster scoped resources that are part of our Helm charts and our operator releases. Think CRDs, ingress classes, anything that is not scoped to the namespace is really tough to isolate. We've worked around it to some degree with prefixing or suffixing resource names to keep them mostly separate, but it's not a perfect solution. And also it's really tough with CRDs as well because of their global state. So I see this being a huge help back to the root problem that we're facing here, because the main issue here is it takes a good amount of time to spin up those clusters, write the tooling around the management for that, and install the dependencies on them. And then another amount of time to install the agent and get that connected with the right configuration, and then also connect up CI. So where I see this helping is that we could have auto-updating versions of the underlying host cluster and use vCluster to manage all those virtual ones. So when we need to add support for 127, it would be as simple as running this command to create a new one at version 127, and then we just replicate the CI setup. I do think, given how repetitive these changes are, I think we can probably dry this up a good amount. It would be great to even get to the point, kind of like we tested in the K through S, where we could do a parallel matrix and only have one definition of the jobs and just test at each vCluster version specified here. Would be really great. And that's really where we're at. They even have a Cert Manager plugin I just found that effectively helps you. vCluster will notice that a certificate request is available in that namespace, and it will forward that request to the underlying host cluster to ensure that that secret exists and copy it back up into that namespace. But there's probably multiple solutions we could take for this as well. So that's mostly it. They've got really good docs. I'm still getting familiar with reading all of them and seeing everything that vCluster can do, but I see this being a big help for our infrastructure, which is one of our big limitations and struggles at the moment. Lots of manual work that take up our time from deliverable actions, that kind of thing. So I will stop there. Any questions?
How does scaling work?
How does scale work? Is that what you said?
Yeah, how does scaling work? If you need more nodes in your virtual cluster, does it tell the underlying cluster to scale up, or?
Yes. So in theory, it should. I've obviously only tested with one release here, but because vCluster is actually keeping everything isolated to that namespace except copying the pod definitions out to the underlying host to run them. Let's say we go from 1 to 5 different releases that are in a vCluster. That is still resulting in more workloads being put onto the host cluster. Therefore, the cluster autoscaler should still scale up because it notices that there aren't enough resources to fulfill all the requests to run pods on it. So thanks for bringing that up, because this was one of the limitations of the individual K3s or kind implementations. With vCluster, we still get to take advantage of the cluster autoscaler because those actual pods are still being run on the underlying host nodes.
Thanks.
Mitch, were you like, I didn't quite get the specific, like your inclination on this one, but were you looking at running a persistent vCluster for each version of Kubernetes? Or my idea would be, okay, since we have that great flexibility and it's not taking much time to provision one, we just provision them on the fly for each particular um, pipeline. So basically have, multiple clusters per pipeline provisioned and then deprovisioned at the stop action. Were you looking at it that way, or were you looking at more persistent stuff?
I think we probably could because the like all it's really running is core DNS and its controller, which is K3s under the hood. So let me see. It's requesting 200 megabytes of CPU and 256 of memory. So it actually is really small. We probably could provision per release, which I think would be even better. Because then we're really putting each release in an isolated area. Yeah, because that would address isolation and the issue of spinning up clusters and managing them. So I think that's probably
Yeah.
very, very likely. Yeah.
Yeah, because then we can actually, if we need to introduce a new cluster in the MR, we just add another iteration, like into the matrix, we just add another 127 or 128. And then the jobs are happening only for that particular pipeline until it's merged. And then, yeah, it would be, I see it, if we can make this fly, that would be a huge simplification of our maintenance for the CI cluster for sure.
Yeah, because that vCluster create command would shift from just Kate's 126 over to Kate's 126 dash like branch name, however we calculate the current release name.
Yeah, kind of like that.
Yeah. Yeah, I think that would make a lot of sense. Obviously, this would require a pretty big rework of our CI configuration, but that's probably for the best anyway. It would dry things up quite a bit, make it easier to manage, and make it much easier to add new permutations to test.
I think I saw somewhere that it actually, under the hood, it prefixes the names of the pods, or like when you deploy it, or was it the namespace that it was prefixed? Because
So,
we do have one issue of, the limit of 63 characters. So I'm kind of wondering about that. Are we going to run into this because there's more prefixes now?
yeah, we'd have to see how that looks in practice. I think it looks like it kind of appends its own hash to it, but because obviously these are truncated and it gave no problem, but we would want to make sure that releases wouldn't like the names of the pods wouldn't talk over each other. Yeah, I can test that. I could do a no approach in this MR where instead of all deploying to the same V cluster, I can make a new V cluster for each one and I'll compare the pod names to make sure that all works, but I don't suspect any problems from
Yeah, that would be cool because, like, I think our other problem was, and sometimes still is, the 63 character limit imposed by the DNS.
that.
So,
Yeah, and in the V cluster namespace, it matches that, but yeah, you're right. I am curious how it handles that under the hood when you get back to the host pod name, making sure that they're unique. Just making a note here to test that.
Yeah, there probably is also a limitation on how much version spread we get, just because the underlying nodes kubelet would still need to be compatible. But that's still quite a few more versions than we get today out of the cluster. Like it's going to be guaranteed 3 that we'd be able to use, and like per version, like 3 different Kubernetes versions per version, and probably even more.
Is that from the vCluster kind of definitions, DJ, or is that something else?
So because it sounds like the actual pods ends up running on the node, they'd be somewhat influenced by the node's kubelet, I imagine.
Yeah.
And there's like it's guaranteed to work with like a version ahead and a version behind. So that would guarantee 3 versions. But it usually works with even more than that, right? So we'd have like a guarantee of 3, but it's possible that we'd run into a case where, okay, we've hit a version that now doesn't work on this node version.
Yeah, we should probably ask that. Like Mitch, Joao, and I signed up for their demo, so maybe we could ask that question there, asking how much of a version spread can a cluster support with the vCluster being deployed on top of it.
Yeah, I imagine it depends on like how many incompatibilities are added to Kubernetes itself between those versions.
Yeah, yeah. And only if we can solve the problem of OpenShift the same way, that would be awesome.
But yeah, I guess I just bring it up. It means we should still, when we're redoing this CI, we should still anticipate that additional like actual clusters would need to be attached, just so we don't like fully focus on, we only have one cluster ever, just to keep it flexible. But yeah, I imagine it, I don't know, it's looking really good.
Yeah, it's a great point because since it does reuse those host nodes, we want to make sure that they're compatible, and I don't see lots of changes there, but I would love to ask them how that is translated. On the OpenShift point too, this can run rootless mode, which is great. So you can run it on OpenShift. That said, I don't know if it helps us much because I think our purpose of deploying to OpenShift is that we're interacting with OpenShift's implementation of a cluster, whereas this is K3s under the hood.
Yeah, that's right.
But that would be another good question too. I guess what would have to happen there is OpenShift would have to provide a lightweight implementation the way that K3s is provided. I don't know if lightweight is the current focus.
Well, that's unlikely for the moment. We did ask before for the lightweight implementation, and the consistent answer so far has been no.
Yeah. And thankfully, I mean, a lot of the problems we see today are for Chart CI, and we don't run against OpenShift for those, so still a big help. Cool. Any other questions?
Do you know if images are cached on the virtual cluster or on the parent cluster, the host cluster?
Since it uses the underlying host nodes to run the pods, I would presume that it works the same way that you would deploy them without vCluster. The nodes have if the node happened to run a pod referencing that image before, then it would have a copy of it. If not, it will pull it. This is the similar topic too, by the way. These are the synced resources. So there's a component within vCluster that runs next to K3s that copies objects into the underlying cluster. Most of these are disabled by default, but for example, secret services. So it's actually configured by default that you can talk to resources in your host cluster as if it was a separate cluster, because theoretically it is. You can actually isolate that so they don't have permission to speak to each other, but we might end up using something like that, for example, for like a shared external DNS instance so that they can talk to each other. Same goes for Cert Manager. So something we'll look into, but for example, we could enable its ability to copy ingress definitions back to the host cluster so that Cert Manager and external DNS would still see those requests coming in and ensure certificates and DNS records are provisioned. So it looks like that's how we would be working around that requirement. But the documentation is great. I've linked it in the demo notes here, so feel free to dive in if you're curious. Coming up on time here, but any other questions before we close?
No, this looks awesome, Mitch.
Awesome.
Thanks. For
Thank
coming
you.
along.
Yeah, and thanks for Destin for bringing it up. This is hopefully going to turn out to save us some money and time and effort. So exciting. Thanks, everybody. Have a good day.